Hello everyone, and welcome. So today, we're going to tackle a huge topic in chemistry, the periodic table. Now I want you to think of this thing as your ultimate cheat sheet, okay? It's the key to understanding basically everything. All right, let's get into it.
I mean, seriously, have you ever stopped to think about it? Your phone, the food you eat, your nasi lemak, even you. What are we all actually made of? Well, the answer to all of that, it starts with these super tiny building blocks of matter we call elements.
So here's our game plan for today. We're going to start with the absolute basics, then we'll explore the periodic table itself, our chemistry map. We'll learn how to tell the different elements apart, see what happens when they get together, and most importantly, we'll finish up with some exam superpowers to make sure you nail your tests. You ready? Let's go. Okay, first things first. Let's imagine we have a super-powered microscope. We're going to zoom in, way in, to see what our world is truly made of.
So at the very bottom of everything, you've got atoms. And the best way to think about an atom is like a single Lego brick. You just can't break it down any smaller. It's the smallest possible piece of any element, and you use these bricks to build everything else.
Now, what's inside that Lego brick? Well, it gets even more interesting. There are three tiny particles inside. You've got your protons, which are positive, electrons, which are negative, and neutrons, well, they're neutral, no charge. So here's the key question. Why is an atom neutral? It's because the number of positive protons is always perfectly balanced by the number of negative electrons. Simple as that. They just cancel each other out.
Right. So if you have a massive pile of identical Lego bricks, let's say they're all red, that's basically an element. An element is a pure substance made up of only one kind of atom. A piece of gold, it's made of only gold atoms. The oxygen we breathe, only oxygen atoms. You get the idea. It's the purest thing you can get.
Okay, so with all these different types of atoms, how on earth do we keep track of them all? Well, that's where this beautiful thing comes in. It's our ultimate chemistry map, the periodic table.
And this is the magic number, 118. That's how many unique elements we've discovered so far. Every single thing in the known universe, I'm talking the air you're breathing right now, the chair you're sitting on, even the most distant stars, is made from some combination of these 118 building blocks. And here's a cool fact. Some of the newest ones were made in labs, and they're so unstable they literally disappear in a fraction of a second.
This incredible chart didn't just pop out of nowhere, you know. It took a long time to figure out. It started with guys like Antoine Lavoisier, who made that first big split, metals and nonmetals. But the real superstar was Dmitri Mendeleev. Back in 1869, he didn't just arrange the elements by their properties. No, he was so confident in his pattern that he actually left gaps in his table for elements that nobody had even discovered yet. Can you imagine that? And guess what? He was absolutely right.
So what's the secret code? What's the one simple rule that organizes this whole thing? It's the proton number. That's it. Element number 1, hydrogen, has 1 proton. Element number 2, helium, has 2 protons. Element number 3, lithium, has 3 protons, and so on, all the way to 118. It's so simple, but so powerful.
Okay, now that we know the code, let's look at how the table is basically split up. Think of it like two main teams. On one side, you've got the metals. On the other, the nonmetals. Oh, and there's that special group of inert gases all the way on the right. Knowing the difference between these is absolutely key for your exams.
And this table here breaks it down perfectly. Just look at the differences. Metals, they're usually shiny. You can hammer them into different shapes. That's what malleable means. You can stretch them into wires. That's ductile. And of course, they're great conductors of heat and electricity. Nonmetals, on the other hand, are pretty much the total opposite. They're dull, they're brittle so they break easily, and they're terrible conductors. You really need to know these properties, so maybe pause here and take a good look.
All right, elements almost never just chill by themselves. They love to get together with other elements, but how they get together is super important. Now, this is where a lot of students get mixed up, so let's make this crystal clear.
So, what's the big difference? Think of it like this. A compound is like making, let's say, a whey. You take your flour, sugar, and coconut, you mix them, you cook them, and you've created something totally new, right? A chemical reaction has happened. You can't just pick the sugar out of the whey anymore. That's a compound. Now, a mixture is like making rojak. You just toss in the fruits and the sauce, you've just physically mixed them. You can still see the pineapple, you can see the cucumber. You could pick them out if you wanted to. No new substance is formed.
And this idea connects directly to the type of change that's happening.
Making a compound, like arqué, involves a chemical change. You form a completely new substance. A good example is burning paper. It turns into ash, and you can't turn it back into paper. A mixture, on the other hand, just involves a physical change. Think of ice melting into water. It looks different, sure, but it's still H2O. No new substance was created. You can freeze it and get ice again.
Okay, so here's the cool part. Since mixtures are only physically mixed up, that means we can also physically separate them. So let's look at how we, as chemists, can clean up a Rojek-style mess.
One of the most common ways is filtration. This is perfect if you have a solid that doesn't dissolve in a liquid, like sand and water. You just pour the whole thing through filter paper. The liquid, we call that the filtrate, goes right through. But the solid, the residue, gets left behind. Easy, right? Of course, you have to use the right method for the right mixture. If you had iron mixed with sand, you'd just use a magnet. If you had salt dissolved in water, you could use distillation. Boil the water off, collect the pure steam, and the salt gets left behind.
All right, we've gone through a lot of stuff. Let's pull everything together now and focus on what you absolutely, positively must know to ace this chapter in your exams. Think of these as your new superpowers.
Okay, here they are, your superpowers. Number 1, know your subatomic particles. Proton, neutron, electron. Easy. Number 2, be able to look at any periodic table and point out where the metals, nonmetals, and inert gases are. 3, you have to be able to look at a mixture and choose the correct way to separate it. And finally, the big one, the one that gets you the HOTS marks, you need to be able to justify why an element is used for a certain job. For example, why do we use copper for electrical wires? Don't just say it's a metal. Say, because it is a good conductor of electricity and it is ductile. That's the A+ answer right there.
And please, remember this isn't just about passing exams. The reason this stuff matters is because understanding the periodic table is how we build our entire world. It's how engineers choose the right metals to build skyscrapers. It's how doctors develop new medicines. It's literally the language of science that makes everything possible.
So, I'm going to leave you with a final thought, a bit of a challenge. Now that you know the building blocks of literally everything, which single element do you think is the most important for life? And, more importantly, can you tell me why? Use what you've learned. Think about it. Thanks so much for tuning in, and I'll see you in the next one.